Neutron stars are one of the most fascinating celestial objects that can be found in our universe. These incredibly dense objects form when a massive star collapses in on itself, causing its core to shrink to the size of a city. This produces a star that is extremely dense, with a mass equal to that of the Sun, but a diameter of only a few kilometers. There is something special about M82 X-2, even among neutron stars. M82 X-2 is a neutron star in the Messier 82 galaxy, 12 million light-years away. The gravitational field of this star is not only incredibly dense, but it also radiates 10 million times more energy than the Sun does. In spite of this, scientists are still trying to figure out how it is able to support itself. The Eddington limit determines how much light an object can emit based on its mass. Stars and black holes can only exist if they maintain a balance between radiation pushing outward and gravity pulling inward. The M82 X-2, however, appears to be able to defy this limitation. According to recent research, M82 X-2 steals material from a neighboring star at a rate of about 9 billion trillion tons per year, which is about 1.5 times the mass of Earth. The material rains down onto the neutron star's surface, heating up as it approaches and causing the star to emit a great deal of energy. M82 X-2 has an extreme gravity, which means that even something as small as a pea landing on its surface can trigger an apocalyptic nuclear explosion. According to the Eddington limit, particles that surge into space are pushed aside by outgoing photons, but in the case of a neutron star like M82 X-2, particles become filaments that can dart through the outgoing blast. In spite of the enormous amount of energy M82 X-2 emits, scientists struggle to understand how it is able to keep itself intact. We are unable to fully understand the extreme conditions present on this neutron star based on the laws of physics as we currently know them, so researchers continue to study it.